Hey, welcome to Mathnasium's monthly math movie March edition. We're gonna do a bunch of stuff this month. We're gonna do a quick review of what we just did in February. We had Valentine's Day grams. Yesterday was February 29th, very special day. We don't always have February 29th. Doesn't happen every year, does it? Leap day. And I'm gonna interrupt looking at March to talk about our number of the month. This month is going to be, now this one's going to be a little trickier because we got some decimals here. 365.2424. I didn't say that proper with place value. It's 2,424 10,000ths, but that's awkward. And I know how to say it that way. So 2424, and then what that number is, it's the actual, almost, number of days in a year. It's been rounded off for entertainment purposes to that many decimal places, just to keep it more fun. So what's the deal? The Earth goes around the sun. That's called a revolution, when it goes around something. And it does that about every 365 days, but it's actually almost a quarter of a day more. So almost 6 hours more it takes for the Earth to go around the sun. That's just because it spins on its axis. That's a day. It kind of does that sort of independently of the going around the sun part. Other planets like Mercury, it's really close to the sun and it's pretty small. It actually is synchronized, its rotation with its revolution, not exactly perfectly like our moon is. It's like 3:2 or 3:1. There's some sort of integer ratio. Anyway. We don't need to talk about that. Basically, the Earth spins around, it stays pretty much independently of going around the sun. And so it's not a nice round number that fits into our calendar. We like to make calendars and have them repeat from year to year, and then we can predict when to plant things and stuff like that. So, so we had to fix it. And the way we fixed it, Julius Caesar, I guess, down in his day, kind of gets credit for it because he created a month, July, named it after himself, put it right in the middle of summer when it's nice and they can have festivals and sit around and be pleasant. He wanted that to be his month. They realized after, a couple of decades that it was like snowing in July because their calendar wasn't exactly synchronized with Earth going around the sun perfectly. So it got off and they said, we need to fix this. And so they did a bunch of things. They added some months and it gets pretty complicated, but this idea of leap day came up, and we all know, if you know about leap days, if you don't, here's how it works. Every 4 years, we add a day, and we put it in February, which is already kind of short. Again, the Romans, they hated February. They made it the even month and shorter. But anyway, we give it to February because it's already kind of short, and that kind of mostly makes up for it. And that's the one that we all kind of know. Every 4 years we add February 29th, except there's two exceptions, and they don't come up all the time, so we don't really talk about it normally, but they actually did come up recently. Every 100 years, every century, every year where there's 2 zeros on the end, it normally would be because of the way we lined up every 4 years, but we don't do a leap year on those years. So we fix it a little bit more by not doing a leap year when normally we would. And then the second exception, or the third rule, is every 400 years, or every 4 of the centuries, we do a leap day. So we only skip 3 of the 4 centuries. We actually do the 4th one. And then this actually just recently happened, and a lot of us weren't aware of it because things just kind of happened like normal. So 2000 was one of the 4-year cycle, so it would have been a leap year, but it's a century because it ends with 2 zeros. So it wouldn't have been a leap year, but it's one that basically you look at the 20 part of the 2000, and if 4 can go into that, which it does, then it is a leap year. So 2000 was a leap year, just like most people thought it would be just because they only knew the first rule. Anyway, here's how the math works. This is where it gets interesting. So I wrote a big equation on the top. 1 year, we know it's 365 days. And then we're gonna do the 3 corrections. The one is every 4 years we add a day. And I'm gonna write that as every year is a fourth of a day extra. So every 4 we get a whole day. I'm going to just spread that out amongst each year. It gets 1/4 of a day. Similarly, that every 100 years we don't make it a leap year is we're going to subtract 1/100th of a year of a day each year. And then every 100 years, that's going to add up to another day that we're going to subtract. And then the third correction is we're going to add back a leap year every 400 years. So this setup is kind of crazy, but those are the corrections that we do for our leap year account for calculation. And then it could get kind of nutty if you do common denominators and deal with the fractions. So I'm going to do decimals because these are kind of friendly. A quarter, some of you might know, or at least enough that you know, like a half is 0.5. Well, a quarter is 0.25. That's pretty friendly. It's 25 hundredths. And then we have to take off a hundredth. Well, the hundredths are the second decimal place. In this case, the 5, because we have tenths and then we have hundredths. So we're going to take off one of the 5 hundredths that we have to turn into 4 hundredths. So that's dealing with the minus 1/100th. And then we have to add on 4 hundredths, and there's a few ways you could think about 4 hundredths, but I like to think of it as it's 100th of a quarter. It's a quarter, again, divided by 100 with 2 zeros. So we know what a quarter looks like. We just need to shift that over a couple of spots and put 25 over here in the 10,000ths place. So that's how that works. So we pretty much build our actual value of a day is 365.2425. And that's really close to the actual rounded off value of 365.2424. It's good enough for 10,000 years. If we just do this, follow these rules, we'll be good. We'll slip 1 day in 10,000 years if we follow these rules. So that's pretty good. And that's how it works. I like to tie that in with the math. Maybe if we talk about those exceptions, they get a little bit complicated, but that's cool. Number of the month is going to be posted up on the bulletin board back there in case you didn't know, if you want to read all the words. And see all the details and look at my pretty pictures. Okay, next let's do the estimating jar. This was February is this one. This was our Sweethearts jar. It's a ton of sugar in there. Don't eat all the sugar. It's not good for you. Share it, give other people the sugar, and then not so many people get sick, or more people get less sick or something. I'm not sure how it all works out. I went ahead and I tabulated, I recorded everybody's estimation, put it into Excel. I did my chart. This just kind of shows what people were guessing, more or less. And I plotted the actual value, which was, in this case, 399. Kind of a wacky number, but if you guess a nice round number like 400, like Nathan Alvarado did, guessed 400, he was off by 1. Guessed a weird round number, and he won it. So good job, Nathan Alvarado. You get the guessing jar this month. Again, share it with your friends and family. Pretty good. And the average for everybody's values, I kind of tossed off the ones that were like 10,000, you know. You got to think a little more clearly about what 10,000 means. That's not 10,000. So I didn't treat those in the average, but the average came out to be 465 of this collection here, which was pretty close. So you guys as a whole are pretty good, the collective mind. So good job with that. There's actually a couple others that were really close. Notable mention for Whitney Cortez. I think she actually won last time, and maybe even like one before that too. So Whitney guessed 402, so she would have been the winner if it hadn't been for Nathan. And really, really close. There were a bunch of 380 somethings that were also really close to, so pretty cool. 399. The new jar is out there. It's I'm just calling it Easter treats, and treats doesn't mean you get to eat everything inside. Some of it's decoration. So there's shiny little things that look like eggs that you can't eat. And there's other things, the little eggy things that are shiny that you can because they're jelly beans. But then there's other shiny little things that you can't because they're glass. So maybe just be careful with that if you win that one. Just a warning. But we had fun putting that together. It looks nice out there. There's a new jar. Okay, let's move on to finish the fun stuff. Let's talk about March. Since it's already March 1st. March 6th, our first big thing here is National Oreo Day. Yay, Oreos. Who doesn't like Oreos? So we got a deal if you you got to complete 5 pages, come in and finish 5 pages, and you get Oreo. Packaged Oreos, so that's pretty cool. And then coming up, this is March. We all love March in Mathnasium because it's got Pi Day. Pi is just a fun number in math. It comes up all over the place. We use it in a bunch of formulas and not just things dealing with circles, weirdly. I studied physics, and there's some like stuff that doesn't have anything to do with circles, but there's pi like pops up, or like square root of pi. So anyway, pi is kind of an important number. I gotta just say right now, it's not as cool as tau though. Tau is better than pi. I'm just putting it out there. Tau is 2 pi, and we should have just done 2 pi as our constant, and everything would be better. Anyway, we got a Pi Day party coming up. I don't want to disparage pi too much, but March 14th, 314 is first 3 digits pi, is going to be Pi Day party. We're not going to have instruction. We've canceled your sessions. We've already talked to you about that, hopefully. We're just going to be having a party, so come when you want. We're going to be open all, for a big block of time, but just come and have as much fun as you want and then leave. Bring friends and family. We're going to have treats. We're going to have fun activities. You're going to learn about pi, obviously. We have a partnership this year with Baskin Robbins, so we're doing some stuff for them. They're doing some stuff for us, and we're going to have polar pizzas, which are ice cream pies that we'll cut up and share, and we'll maybe have regular pizzas and cookies and other round shaped objects and things like that. And I'm going to talk about at the end our center activity that's going to be going on for the next couple weeks at the end of the video. So that's Pi Day. Put on your calendar. It's going to be fun. Just come and check us out. Have some treats and leave. You don't have to stay and do a bunch of stuff if you don't want to, but you will. Okay, we're going to do some, we got St. Patrick's Day coming up. Wear green. It's just fun. Do some green. I can't read what it says up there upside down. My bad eyes. We got bingo coming up for fun, and then a sneak peek in April Fools is we're going to have math riddles for treats. So that's our fun stuff. And let's see, let me move this stuff over here. I skipped right over, I was going to do Student of the Month. Let's do Student of the Month. Student of the Month this month was kind of a toss-up last month. We had a couple that we were batting around, and we kind of picked one, not the other. So this month is going to be the one that we've been thinking of for a long time. Nathan, not the other one, Nathan Gangisetti. Nathan is in, I think, 2nd grade, if I remember right. He's great to have around. We love having him. I just dropped my notes with this, with the quotes. We asked the instructors, hey, what do you think about Nathan when he came up? Happy and dedicated, so he works hard, but loves doing it. Smiles a lot, and who doesn't like to be around somebody who smiles a lot? It's contagious. Does a ton of pages, one of the instructors said. So he works hard. He actually does the math and not just has fun. And super excited. So it's just contagious to be around Nathan. We like having him around. He's great mathlete. So he's going to be our Student of the Month. This is going to go up in the window for a couple years while we have space. So everybody's going to see Nathan's name. He's going to get this to hang on his wall, a certificate. 25 punch cards to spend in our reward cabinet. Good job, Nathan. And for your lawn, here, let's do this. Student of the Month yard sign to put up in your yard, and take pictures of it and share it on have your parents put it on all over social media. So that's good, Nathan. All right, what else do we have? Raffle. So I've already conveniently, I didn't want to fuss with it, so I've already dumped raffle tickets in here. And okay, just want to double check. So we are drawing for the $100 bill. This is going to be, these are the raffle things. Ooh, I felt, oh yeah, that's the one right there. That is Anahita. Anahita, you won the $100 bill. Yay, Anahita. All right, and let's draw for first runner-up. second place, depending how you count it, is going to be Kara. Kara or Kara, hope I'm saying that right. I just said it wrong at least once. You are the first runner-up. You get old style 25 punch card to spend in our reward cabinet. And second runner-up is going to be Ion Agarwal. I think Ion might have just quit, but so I'm going to draw another just in case this doesn't work out. I want somebody to win, but if we can do Ion, I think maybe Ion's not with us anymore. I got Luke as a runner-up for Ion, so I'll have to see. I'll have to see how that works. We should have thought about this. Maybe this contingency. Anyway, that's worth 10 punch cards with the new style in our reward cabinet. And then the last thing I want to do while I got time is I want to show you guys something that's going on out in the center. Let me do this without turning it off. Yeah, are we still going? Yes. So this is our center activity we've been doing. We're doing all the digits of pi. You get to pick a plate, pick the next digit of pi, which in this case would be 4, and you're gonna draw it with crayons or markers or whatever you want, a big number. We got a couple going on here, and then they're all gonna go on the wall. Look at all the digits of pi. Now, it's been a bit of a struggle for me personally to get these to stick on the wall reliably, but I think I got it, and there they are. I don't know how many that is, but we're going to there, and here's my goal. My goal is to cover the entire wall with digits of pi all the way to the corner. So we're gonna finish this first, and then we draw a line up there and restart at the corner and go all the way across and all the way across. We can do it. We got 2 weeks to do it. And I got all these plates, and I got 2 more stacks of plates on the way. Let's do it. I got this many digits of pi already printed out, but I have a binder that has 1,000,000 digits of pi, so we can go as far as we want, but you guys got to do it too. Somebody, I think, might have said you only get to do 1. I think that was 1 per day. I think that's what that person meant. So that's what we're going to do. That's the end of the video. Have a good month. We'll see you around Mathnasium.